All right, guys, welcome back. Today we're going to talk about an inscribed angle. An inscribed angle is an angle whose vertex is on the circle and whose sides are chords. So we need to recognize the difference between an inscribed angle and a central angle is that we have to have the sides being created by chords. Typically, that's what people forget to look for when they're comparing an inscribed versus a regular central angle. All right. Excuse me. When I create a inscribed angle, he has what's called an intercepted arc. That's the arc in between the two chords, and the angles, again, the resulting angle from the chords. We determine that if I'm looking for this angle, it's going to be half of that arc, or to go backwards, if I'm looking for the arc, it's going to be double the angle. So we're going to use this to determine problem 1 and 2. Maybe get some colors that might help visualize this a little bit. So I need to find the values of A and B. So if I look at A, I see A goes around this arc of PT. And that arc of PT corresponds, actually, I'm going to use my highlighters so we can still, see the picture beneath it. So A is that arc, and it hits this angle. And I see that angle PQT is a measure of 60 degrees. So to get to A, it's equal to 60 degrees times 2, because it's twice the size, which is 120. So A is 120 degrees. Now I'm looking for B, and B is an inscribed angle. And he's this specific inscribed angle. So he's most of A, and then a little extra. So to solve for B, I'm going to take that 120, and I'm going to add that extra 30. But B's half of the outside, so I'm going to divide him by 2, which that is equal to 75 degrees. Problem 2 asks me to determine the angle of PQR if arc RS is 60 degrees. Okay, so I'm going to take all of my outside pieces, so 120 plus 30 plus 60. So 150 and 150 plus 60 is 210. And then I want half of him because he's an inscribed angle, so I'm going to divide that by 2. So that angle is 105 degrees. Problem 3, we're going to use the following picture. And again, I'm going to get some highlighters out so I can see. So I'm going to go after X first. So angle X is here. And he is created from this big giant arc. So I need to take 80 and 70 and I add those together and I get 150 again. And then again, he's half the size, so he's 75 degrees. Y is this distance. And I need this, oops, I forgot I can't do curves with my highlighter. Huh. One moment. It uses part of this arc, so I needed to figure out what this arc degree is first. So I have 360 minus 90 minus 80 minus 70, which gives me a total of 120. So to find Y, I'm going to take that 70 plus 120, which gives me 190, and I'm going to divide that in half. So Y is 95 degrees. Corollaries, remember from Math A, a corollary is something that follows directly from a theorem. So I've got some corollaries describing inscribed angles. Two inscribed angles that intercept, which means hits or create. I like the word hit better so I can see that, boom, they're touching. So any two inscribed angles that hit the same arc are congruent, which means they're equal. Any angle inscribed in a semicircle is right. Well, think about it. A semicircle is 180 degrees. We know that it's half of it, so half of 180 is 90. And then opposite angles of a quadrilateral are supplementary. And remember, supplementary means that we add to 180. I am trying to type. Why isn't it letting me type? Thank you. Oh, what on earth? Add to 180. I don't know why that 9 and the equal sign came in there, but okay. So using that logic, let's do the following. Again, going to kind of highlight. So it asked me to find the measure of the numbered angles. So in this case, angle 1. Angle 1 is right there. I see it hits the semicircle, so that has to be 90 degrees. Angle 2, well, it's created from this arc. And I see that it's also got this also inscribed angle here. And notice how they both hit this arc here. So since the arc is congruent, the angles must be congruent. So that's also 38 degrees. Angle 1 and angle 3 hit the same arcs. Well, it hits a semicircle, so they're both the same value. So 1 is 90 degrees. 3 is also 90 degrees. 4 and 2 doesn't have anything on its arc. If you follow that in, it's almost basically, it's kind of different. It doesn't have anything on that arc, so we have to use 4 in order to figure out 2, which is here. So 60 and 80, which gives me 140. Half of 140 is 70. I need my pen. So angle 4 is 70 degrees. And then to determine angle 2, they add to 180, so 180 minus 70 is 110. Okay, anything that involves a tangent in a chord is half of the intercepted arc, so same kind of idea. I'm gonna move my camera for this one. In the diagram below, K(J) is tangent to a circle at J. Find the values of X and Y. Oh, where do I want to begin? So I'm looking for the angle of X, and I'm told it hits here. If you notice, that's kind of that tangent line with the arc. Or I'm sorry, tangent line with the chord, which is what I see above. So it hits this green arc right here of JL. Oh, no, I want that arc. I don't want a straight line. So it hits that guy. So because it hits that guy, let's see if anything else hits that guy. Well, look, if you follow, it also hits angle Q. So angle X, angle X is equal to angle Q. And angle Q is 35 degrees, so angle X is 35 degrees. What is going on? Now I need to find angle Y. So I'm going to go ahead and clear my picture a little bit. Angle Y is here. And I see it's got something to do with the semicircle. So if angle Q is 35 degrees, that arc of JL has to be twice, which is 70, right? That's what we've been working on this whole time. And I see that I have a semicircle, and a semicircle is 180, so 180 minus 70 is 110. So this arc between J and Q is 110 degrees, and I see that's where I need to deal with angle Y, and it's half of 110, which is simply 55. All right, last one. I like that to go away. I see that I have vertical angles here, or I have this cross, which means that in here must be 54 degrees. That's really hard. This angle must be 54 degrees. Since I have a linear pair, I took 180 minus 126. It's asking me to find the angle of, find the measure of BRT, B to R to T. Well, hey, doesn't that guy hit the same arc right in here, this little guy? No, I want a curve. I want a curve. Come on. Stop being dumb today, computer. I want this curve that hits that same one, which is a central angle, not an inscribed angle. So the angle BRT is simply 54 degrees. I'm sorry, he's half of the arc. Why do you keep typing a Z? So my arc is 54 degrees, so he is half of that. So he's actually 27, I apologize. We're not talking about the arc, I'm looking for that angle. The angle is half of the arc. So I found the arc, so there's the angle. Whew. And then it asks for T to, I'm gonna look for T to R to S. So this guy. So I see that it deals with part of a semicircle. All right, I'm gonna have to come back, guys. We will finish this problem and we'll go through our formula book when I have some more time.